Good afternoon, morning, everyone. Again, my name's Jay Meszar. I'm a senior applications expert here at Imagine It on our reality capture team. And for me, that means I get to play with some really cool equipment and really cool software and overall help people look for solutions that are going to fit their needs. And one of the things that tends to come up over my discussions with a lot of folks is how can they use reality capture for design and layout? And so that's kind of what we're going to talk about today. Before we dive in, just a little bit about myself. I've been working in the AEC reality capture space for about 27 years, so it's been a long time. I started at Imagine It 16 years ago, and so I've been here a long time. If you haven't taken a reality capture class with me, you might have taken a Civil 3D course or possibly an AutoCAD course with me over my time here at Imagine It. I am a Civil 3D certified professional, and I've been working in our reality capture services team for roughly about 8 years now. So again, I've kind of seen a little bit of everything when it comes to reality capture, all the different scanners that have been out, and um, of course, all the different software workflows. Some of them have been a challenge, and some of them have been just fantastic. And I really believe as we go forward here, these workflows just seem to get better and better as technology evolves. So let's talk a little bit about what the webcast is about and what we'll be talking about today. You know, to start, what's your existing data being used for? Obviously, when we talk about reality capture and scanning, um, we're talking about capturing those existing conditions. But I think one of the things that we want to talk about here is how are we using that data for the design portion of our projects? And we're going to talk a little bit about that today and um, talk about how existing measurements, are they good enough? We hear that so many times. Oh, we're measuring with this type of device or that type of device, and we think it's good enough. And so the question is it good enough? In some cases, it may be. Some places it may not be. I can tell you if you're walking around your projects with your hands to measure a space and then walking somewhere else to write that down, probably not good enough. But we'll talk about some of the different devices and how they pertain to whether measurements are good enough, right? Um, what type of devices can be used for to capture existing conditions? And finally, how does this relate to design? Again, we talk about capturing existing, and I feel like a lot of times people overlook how that data can be used during the design process and what what can be done with that existing data to help us design. So we'll take a look into a little bit about that. Ultimately, we'll then, kind of pause, and I'm going to do some real quick demos. I'm not going to get anything too specific or too hard or anything like that. Just kind of talk a little bit about what can be done in maybe the different verticals, what can be done in a civil space, or what can be done in a mechanical space, or something like that. So let's jump in, uh, and let's talk a little bit about data use. Again, we have all of this data, and probably one of the biggest comments I get about reality capture come from some of the engineers or sometimes drafting techs or designers, and the question is, I got all this point cloud data, what do I do with it? How can it be used? And so we can use this point cloud data in the civil engineering space. And, I like to talk about this because, when I talk to civil engineers, sometimes a reason to not use the data is, well, over all these years, we have our surveyors go out and they give us uh, data that's good enough. And I don't disagree with that. A lot of surveyors do a fantastic job and in giving us the data we need to design a roadway or a site project. But one thing that I like to talk about when it comes to civil engineering and scanning is think about the surveyor. Think about the person who's on site for a moment. We've all driven down the highway and seen all the road signs where survey crew in progress or something like that, right? Well, unfortunately, I think not enough people slow down to think about those folks standing on the side of the road. And so when it comes to civil engineering and getting that existing data, you know, um, safety can be an issue. And with a scanner, we can get a scan of an entire roadway very easily and very quickly without having to send a person into the middle of the road for anything. Okay, so think about that a little bit, and then we'll talk a little bit more about the design aspect as I go forward here. Right, surveying existing conditions. Now, if you take a look at this parking lot here, you can see it's rather large, and I certainly didn't scan the whole thing, but I was able to get a good curb layout with this in really 45 minutes, right? Took some scans, imported it into the computer, put it into Civil 3D or whatever you use. I use Cyclone 3DR as well, and was able to get good COGO points into Civil 3D. Okay, so not only are we taking the time that we're spending in the field, we're cutting that down in a fraction, right? By being able to take a scanner like you see here, an RTC 360, and think about, even if I scan on a high setting, I'm getting a full scan with color imagery and all of that for less than 3 minutes. So that's a lot of data, okay? We can create 3D surfaces. So what you see here, the purple is just creating a DTM very quickly from a point cloud. And granted, you'll see some little spikes in here and things like that. But what I wanted to talk about here is while this surface is not perfect, the site that I'm interested in, down there by that little gas station in the middle, I got a very good surface from and took it into Civil 3D. Now, think about, for all of you civil users out there, think about taking a very large point cloud like this one and putting it into Civil 3D. Comes into AutoCAD pretty well as a recap file, but what if I can turn it into a DTM in a matter of minutes? That's possible with point cloud data and the right software, right? And I'm not bashing Civil 3D by any means, but to create a surface from it is really difficult because it takes a long time, okay? What about measuring volumes? Getting data from a dirt pile, a rock pile, a coal pile, whatever it may be, we can come in and calculate whether this comes from a terrestrial based scanner or a drone or something like that. we can bring that data in and calculate volumes from these surfaces. Now, what you're looking at here, I use a software created by Leica called Cyclone 3DR. It has a great stockpile feature where I can come in and very easily draw a line around the outside of my pile and save that line for later. And as that pile diminishes, keep calculating volumes to get differences. Okay? So things to keep in mind. What about the manufacturing space? Right? All kinds of stuff out there. We want to find out where our pipe routings are. We want to find out where tanks are. Or we simply want to take the layout of a space, get rid of everything inside a specific area, and try to find something new. What about taking an existing floor layout to accurately install new equipment? If we take a look at the image here, look at the equipment near the bottom of the screen. If I was to take that all and make it disappear, either by hiding it or deleting it, I could bring in designed equipment and say, hey, is this going to fit in the space that we have from the other equipment? And keep in mind, again, I could send a team of folks in here with each one with their own, measuring tape. Probably not going to get the same measurements from each person. Having a scanner coming in here and taking again, just that bottom area there, I might be able to get that done in maybe a half an hour. Import it in, and I can cut a slice through the whole point cloud to be able to see all of that data very easily, very quickly. And above all, very accurately. Okay, whoops, my image didn't go away. What about designing on top of a point cloud? What if we scan equipment and we want to add proposed data to the top of our point cloud data? We can do that as well. So again, just keeping your mind open a little bit, thinking a little bit outside the box, and deciding what can we use this data for. Is that, my biggest thing is this going to fit? We already know before we have somebody build new equipment and take it to the site. Right? And so now let's talk a little bit about, are your measurements good enough? I think probably everybody's had a project go south on them at one point or another. And, when those projects go south, you can see there, that costs us a lot of money, right? And so when we take teams out and visit a site, how many times are we revisiting that site? And how much is it costing us to visit that site? Right? We're throwing piles of money at revisiting between hotels and food and rental cars and sometimes flights and things like that. So are your measurements good enough? Is a tape measure good enough? Now, many, many years ago, I worked for a different company who basically sent teams of people out to measure hotel ballrooms. And they would bring it back. CAD folks would put that into the computer and make sure all the measurements fit. Very, very rarely did a polygon close with tape measure measurements. And so we want to think about that. right? Because if we measure a wall that's 12 feet and we measure it at 11 feet and 11 and 7/8 inches, you know, that starts to work its way around a space. All right. So the next question again, are those measurements accurate? You know, forget the tape measures. Are you using the correct scanning equipment sometimes? We want to know, is that scanning equipment accurate enough? You know, I like to use a saying that um, just kind of sticks with me, and that's there's a right tool for every job, right? And just because you have a scanner doesn't mean it's the right tool for every job. Certainly, certain scanners are made to do different things. So we want to know, are those measurements from that scanner accurate enough? And we'll talk about that too. My example of, does the polygonal room close, right? And I'm actually sitting in a hotel room looking around this room and thinking about all the different little bump outs and doorways and things like that in this room. And I think, boy, if I had to measure this by hand, or if I didn't have a scanner that was accurate enough to scan this room, I could end up with some bad measurements, right? So do you need the most expensive equipment to get great measurements? No, you don't. Certainly, there are some scanners that do things better than others, but you don't have to have the highest priced scanner, okay? And so what about piping extraction? For those of you in mechanical spaces, right? We have our mechanical plant folks who have to find pipe routing. Are their measurements good enough? Are they able to get pipe data coming out of this? And therefore, not only be able to measure the existing pipe, but know whether their newly designed pipe is going to fit on that existing pipe. Bringing equipment in. I've heard this one quite a bit, where folks are trying to bring in new equipment, but it has to sit level. They want to know, is the concrete floor level enough? And again, using the right scanner, using the right software, we can do a floor flatness analysis and be able to find out, where are those dips in the floor, or those bumps in the floor that are going to make that new equipment not sit level. And by the way, for those of you who may not experience, floor flatness is in a bunch of the Leica softwares, right? The image you see here is from Cyclone 3DR with some labels. There's CloudWorx for Revit has a floor flatness analysis tool. CloudWorx for AutoCAD has a floor flatness tool. So it's not just in one software. Sometimes I want to know, hey, this new equipment we're putting in, does it clash with any of my existing data? That's a huge one for design and layout, right? We can not only do one scan and try to figure that out, but we can do scans over time and be able to compare those scans to our design to see if, hey, did somebody put hangers in the wrong location and now there's, I don't know, fire suppression system in the way. right? Is there somebody put a wall one way or the other, or cable trays, or whatever it may be? We can find out, is it hitting our design? And if it is, we know we either have to adjust our design or make whomever put it in our way go back out and change and put theirs in the correct location. All right. So I kind of mentioned the right tool for the job a little bit earlier, and that's where this slide comes in. And are the scanners important? To me, they're very important, right? There are so many scanners out there. This is some of Leica's scanners, right? And there's, I mean, other brands and um, models that, I mean, we could probably go on for a couple of hours about all the different scanners out there. We're going to talk about the Leica ones here today. And are they important? Sure they are. What's the difference? Well, there's a big difference in all of these scanners, right? Some of them get more data. Some of them get less data. Some of them work faster than others. And so we want to know which ones are important, or which ones are important for what you do. So I mentioned scanners have different capabilities. Obviously, size. Size matters here because, boy, look at the scanners you see there, and their size kind of, well, we have some a little, I have some a little blown up here, and some are maybe a little smaller than they should be. But the scanner in the top left there is very, very small. Some of you listening may have a BLK 360. This is about the size of a soda can, maybe a little bit larger, right? It weighs just a couple of pounds. So taking that on a site is very, very easy. Conversely, the one on the bottom right is a P-series scanner. That's a very large scanner. So needless to say, if you're climbing on top of roofs, or having to go through a ceiling, that P-series maybe not the one you want, right? Their functionality is different, right? How they work, um, how much data they gather, and what you use to collect the data. So let's talk about the Leica scanners. Let's kind of walk through them here. The BLK 360, once again, very small, very lightweight, easy to take around a job site, but it is a tripod-based scanner. I don't have the tripod pictured here, but it sits on top of a tripod. We can scan very quickly with that. Just over a minute and a half for the BLK 360 to run one scan. And then, of course, we pick that scan up, or the scanner up, and we move it, and then those get stitched together. Okay, these tripod-based scanners, even though we have to agree to the registration, the stitching together, kind of automatic with the Leica BLK 360. The app tells us, hey, this all goes together. Are you sure you want to put it together? We simply agree with the app if we do. Done. Those two scans are stitched together. Now, moving over to the next, the BLK to go. This is a little bit different. It doesn't sit on a tripod. This scanner is handheld. We walk around with the scanner collecting data. I mentioned I'm in a hotel room. I can walk around this room within 30 seconds and have a floor plan layout imported into the software very quickly. Okay, we'll move on. BLK to go pulse, a little bit different combination of LiDAR scanning and photogrammetry, right? So we're kind of using the scanner to walk through, just like the BLK to go. You can see that you can attach your phone to the top there. And basically the scanner works where we can point it wherever we're looking, and that's the data we're going to collect. So if I want to get the ceiling, I might look up to the ceiling and hold my hand up to the ceiling and collect that data. It's a little bit different the way it works, but still it is us walking around the room and collecting that data. Right? Next one, RTC 360. Once again, tripod-based scanner. We set it down. Very quickly, it collects data, and we're on our way. Very similar to the BLK 360, with the exception of it collects more data faster, and the density of the scan is tighter, and the accuracy of the scan is tighter, is a tighter tolerance. Right? And then we got the big boy there, the P-Series scanner. The P-Series scanner is it's a large scanner, I'm not gonna lie. Carrying it around is a challenge, right? But when you're looking to get the most accurate data at the furthest distances, P-Series scanner is the way to go. Right? When we talk about if and you've never heard of a Leica P50, the P50 scanner can collect data up to 1 kilometer away. That's pretty darn impressive, if you ask me. But you're not going to use that scanner, once again, to get above a ceiling or to get around a room really quickly. It's not what it's made for. We want to use the right tool for the job. And to get around a room quickly, super accurate, I might take my RTC 360, or I might take the BLK 360. If I'm not worried about accuracy, I just want to get a floor plan layout very quickly and without a lot of setting the scanner up and things like that, the BLK to go scanners are fantastic for that. All right, let's look at some of the sample data. This is a BLK 360. This is data I took in my town here, and you can see that along the road there's what looks like a lot of noise, and I wanted to leave that in because it's very important to understand that, you know, the scanner is going to pick up people moving through a scene, or cars or trucks in my case, moving through a scene. And so it's important to understand that if you want to get rid of that data, you can. If all you wanted was a site plan of the building that you see there and maybe a floor plan of the inside, I'm not going to spend the time to clean that data. This is BLK to go data. You'll notice very different looking data, right? It kind of, well, we kind of joke here and imagine that it kind of looks like sometimes spaghetti with the lines crossing each other as you walk through the site. Now you'll notice a bunch of red dots there. Those red dots are not setups. Those are what we call waypoints. And a waypoint is a distance that we set along our walk, and that will give us pictures at each one of those locations. This is some BLK to go pulse data, and you can see it looks kind of sparse, right? And I'll be honest with you, this was just me walking through the house and trying to look at some data and see what we could do. And this is what I happened to have on hand at the time I was setting up this PowerPoint. Now look at the difference here. RTC 360 data. Look how crisp and clean this data is, right? This is in a room with stainless steel, right? You're not going to get this from the previously mentioned scanners. You're not going to get that with this stainless steel or very dark objects. And then this is some P-series data. I worked with a client on some of this data that they wanted to set up and get the data over known control points. And they happen to have a P-series scanner. Perfect. It is a survey grade scanner that will put this job right over top of the control points. If you look closely there, you can kind of see an orange cone where we had a control point being collected. All kinds of different data. Pick the right tool for you, right? And so what I'm going to do now is, before we take any questions, I'm going to actually hit escape here and get out of my PowerPoint. And I just want to show, I'm actually in AutoCAD right now, but this could be Civil 3D, it could be any one of the AutoCAD variations. And I'm using CloudWorx for AutoCAD. And I've loaded in a Leica LGSX file. So you can see that I can take a look at this. I can use my view cube to kind of spin it up into different views. And I think one of the important things here is what I mentioned, this building could be coming down. Let's say we want to get rid of it and we want to start using this data to see if our new site design is going to work. Well, I don't want to do that over top of the other building, because if we're pulling that out of there, I'm going to say, I want to hide that. And I want to do it from a polygon, and I'm just going to do this kind of rough. But you'll see that as I draw my polygon around here, no, I just hit enter. I've now hidden that data. So once again, if I have a new building that's being put on here, I can bring that in and put it in that location. If I were using Civil 3D here, I could very easily come out around the whole outside of this with a 3D polyline and use that as the line that I have to grade to the back of sidewalk, right? So again, placing my design in here. Or what if we wanted to do something a little different? I'm gonna switch softwares here and we'll pop over here a little bit. What if we wanted to do something a little different and we said, let me bring up a data set here. Let's go here and here. We wanted to take our building and we wanted to do something like maybe cut this. Let me convert this real quick. This is going to take just a second here. Sorry for the delay. And actually, while that's doing that, I'm also going to do the same thing over here. So we'll run two at the same time here. All right, there's that one, and this one's still going. All right, well, while we're waiting, then I'll show you here. All right. So I've got my point cloud data in, and we talked about getting the right data. Well, the right data could be, again, a simple floor plan. And that might mean I might come over and just simply pick on a wall, and you can see that now I've sliced through the entire point cloud, and I can essentially see the floor plan here. But what if we want actual AutoCAD objects? Well, we can use this CloudWorx application to do just that. Let me bring this up a little higher. Sure. And then we can simply come in and start clicking on our existing data. And you'll notice that I'm just left mouse clicking and clicking on the point cloud, and I won't go through each little bump out here, and I'll come back to this right here. All right, and we'll come down here. Sure. Again, I'm not going to get each little bump out just because I don't have the time for that here in this, but we'll say close the polygon. Now, you might have noticed that, some people love to point out that, oh, geez, look at that. It didn't follow the point cloud. Well, why didn't it follow the point cloud? Well, because Leica's put in a tool here called ortho. And ortho means it's using the point cloud as a guide to create straight and 90-degree angles. If I had turned that off, we wouldn't see something like this. We would have seen something more like this, right? Where the line wasn't necessarily straight, right? And that's just giving you the option to turn ortho on or off. And once you get what you want out of this, you just simply say send to CAD, close the window, and I'll turn the point cloud off. Bang. I have a full polyline layout of my project. And again, I didn't do the little bump outs because just saving time for that. But giving you options. Now, just as a side note, this happens in Revit as well, right? We can do this same exact thing in Revit to create walls. So for all the architecture folks out there that actually want a 3D model, we can do that in Revit as well. All right. Now, something I wanted to mention here was, I might want to come into Cyclone 3DR and let me go here. Sorry, I got some buttons being hidden here. And I might want to just take a limit slice along the Z axis and look at that from the top down, right? I can then come in and under the analysis tool here, I might grab my point cloud and do a floor flatness analysis, right? Click on a point there and, oops, hit compute, and then next. And then I can compute my floor analysis from here. Okay, I didn't do that very well, but I can compute a floor flatness analysis using Cyclone 3DR. We could do any other kind of analysis. If we wanted to do wall deviation on a flat plane, we could do that as well. Okay. One other thing I wanted to I just want to show it was this pipe trace tool. You can see that these are actually solid objects created from the pipe tracings. Right? So if we were to take the point cloud and turn it off, we end up with solid objects that can be exported to a variety of different formats. And you'll notice this pipe is sized here to come down. So my point in just bringing these up was to not really do a full demo or anything like that, just to kind of show you where some of the possibilities lie and that you can get there with 3D scanning, right? And do layouts. So I guess at this point, we'll go ahead, we'll open it up, Sarah, to questions.
All right, awesome. Thanks, Jay. Several questions came throughout the presentation, so that's always nice to see. First question is more of a comment. It says Jay is awesome, which I can second that. Jay is very awesome.
Who said that? But thank you. Is my wife on here or what?
Andrew Chow is giving you a shout out, Jay.
Thank you, Andrew.
Yes. Next question, how do you know the measurements are accurate?
How do I know the measurements are accurate? Well, I can tell you that, again, depending on the scanner used, that Leica certifies each one of their scanners before they ever leave their factory through a vigorous testing process. And so with that, they are all certified from Leica. So the same way that you would know that any other measurement device is accurate, right? So I guess that's how I would answer that.
Okay. Do you scale the point cloud model?
You know, that's a great question, actually, because a lot of people talk about that and ask that question. So thank you for asking that. You never scale a point cloud model. It is always one-to-one. Okay. Now, with that being said, through the software I have up on the screen, if you had to, you could. I don't recommend it because now you're working with a scale number. And if you get that off a little bit at all, now we're not sure if those measurements are accurate. So I would tell you, no, do not scale.
All right, perfect. Next question. What method do you typically use when aligning and rotating a scan to a CAD file or BIM model?
Great, another great one. Wow, this is awesome. So good question. It depends on how that BIM model or CAD model is laid out from the beginning. So to give you an example, if I have some known points, that's my favorite method, right? And I don't care if they're actually in a survey plane or a known survey coordinate system or not, but if I have some known locations to a BIM model, I would scan with those points and pick them up in the field. And then I can use those points as targets. And I don't have to put targets out there or anything like that, but I can use those as targets to adjust them to the same location and rotation as the BIM model. Otherwise, there are tools within CloudWorx for Revit, for example, where I can pick the point cloud up and move it to the BIM model, or I can move the BIM model to the point cloud, whichever you prefer. I prefer the coordinate method because it's more accurate, but in a pinch, I could use CloudWorx for Revit for that as well.
Okay, the next question says 11 and 7/8 of an inch question mark. Why are the architects measuring anything in the as-built environment? Winky face.
That's an example, of course. I like that.
All right, gotta make it fun, right?
Of course.
There is another question. It says, if you do multiple scans, how do you align the point cloud scan to line up? How do you align the point cloud scan to line up? Hopefully
Right. So you're reading it correctly. Yep. So you do it one of two ways. So I'm going to start with the on the scanners themselves. There's an application that runs on iOS or Android known as Cyclone Field 360. And I can align, or the term is register, those clouds while I'm in the field. That information gets saved to the scanner. And then when we bring that data into the software that hopefully you can still see on screen, you can take those scans and adjust them, adjust the registration in the software if you need to. But typically we do it in the field. And I'll just bring this up real quick to show you. If I had to do it in the office, there's a visual alignment tool, and you can see that these are two separate scans, one blue, one orange, and I would just align them over top of each other, look at their vertical, and join and optimize, and now my scans are stitched or registered together. Hope that answers your question. And for all of you out there that already scan, yes, I know I have a red link here. I was playing around with it and haven't fixed it.
Okay, another question came in. Can you filter the ortho setting for first pass accuracy to save time?
When you say filter, I assume just turn it off. For sure. You can turn it right off.
And this question just says, and why CloudWorx versus Recap?
That's a good question. So CloudWorx, again, it is a application made by Leica, not by Autodesk. Autodesk uses their recap software in which you can bring in the RCP data, right? Now, depending on the software you're working with, whether it be AutoCAD or Revit, you don't have the variety of tools available to you that CloudWorx offers. I'll give you an example. I challenge you to bring in an RCP file to Revit. Click on it. You're not going to see a lot of tools that go with that point cloud. You won't be able to create a wall or a pipe or a conduit or do any sort of analysis, right? And I'm not here to bash Autodesk at all. It's just the way it currently works. With CloudWorx, you can do that. Also, the LGS file, or LGSX file, as it's now known, is a more compressed file, and we get to see more data with that LGS or LGSX format.
All right, thanks, Jay. Next question, what scanner would you recommend for scanning MEP and fire suppression systems?
We should really take that into a conversation and see, fire suppression systems, in my experience anyway, are sometimes very dark piping. And of course, the piping is sometimes rather small, but I would probably steer you towards the RTC 360 there.
All right, next question. What is the recommended pathway for getting LiDAR scans into Revit model?
The software I mentioned earlier, CloudWorx for Revit.
Okay. All right, this next one is a little lengthy. Give me a second. I'm gonna expand this box so I can read it. Okay, this is more of a comment. Remember to talk to your survey team first before you over-expect without understanding the actual data collection process and time required. Sincerely, the survey team, winky face. I see a trend here.
No, I agree with him. Yeah, for sure.
All right, next question. If you need to use the scan to model an existing facility in Revit to do a renovation and you need accurate measurements, which is the recommended scanner?
We really like to talk to you outside this meeting and find out what it is you're exactly doing and what accuracies you're looking for. Again, go back to the slide that I mentioned. Is it good enough? And what is your good enough tolerance? So feel free to reach out to your Imaginate sales rep.
All right, several more questions here still. If there is time, can you quickly show us how to trace a pipe with Cyclone 3 DR?
I can kind of start, but let's see. We're just going to do something very basic here. So I want to extract, click on my my point cloud and go scan to pipe, right? You can see that my point cloud has kind of darkened up a little bit. And if I start a new pipe run, I can just click twice on there. You can see that the pipe has um, already been created, and I can extend or shorten that pipe. When I'm done, just hit enter, and then I can continue with an elbow in this case. And now you can see that the elbow has been placed, and it's done a pretty good job there. But if I needed, I could change the radius of that or shorten it up a little bit. But it did a pretty good job on its own. And then I just simply would continue on to the next location. In this case, it's all the way down here, so I don't need to do that. But that's it. And you can put in valves, and you can do just one single straight piece of pipe and things like that. So I hope that it's very quick. I know, but I just didn't have the setup to do that in the time we have. I know we got you said a couple more questions, so want to try to get to everybody's questions.
All right, next question. Can the scan be geolocated?
It can, but back to our surveyors, right? We're going to need some known locations from the surveyors, and essentially they take traditional survey equipment out, survey GPS or whatever they're using, and they will provide us a text file out of there, or they will provide us a text file, and when we scan, we want those same locations in our scan, whether we set a target up over them or whether I don't like to do this, but we're creating a virtual target on the actual survey pin.
All right, another question. Is there an IFC format for point cloud files?
IFC is not a point cloud format. No, IFC is more of a solid based format that we could export this pipe in, right? Or we could export our Revit models to IFC or our AutoCAD plant models to IFC, not point cloud data, at least not to my knowledge.
All right, when receiving point cloud data that is extremely dense, what is your what is your recommended path for reducing the point cloud data to a more manageable size?
Well, I guess I would like to talk to you further about that because, when it's super dense, we want to know what format that's in and where you're taking it to. Well, as I mentioned earlier, if I got really dense data, I can get it through Register 360 out to that LGSX file. That does such a great job of compression that pretty rarely do I need to cut that point cloud down. But if I did, let's, for argument's sake, say that I did, I might go ahead and do something like take this point cloud here, and if it were too big, I might create a limit box, pare down the limit box, and then export it by just the area that I need it. There are other tools where you can decimate a point cloud, but my thought is, if we're getting all that wonderful data, why are we getting rid of it? So I think if I had to guess, I would say that whoever asked that question is probably using Recap, and Recap struggles with those really big projects.
All right, the next question is asking about upgrading from a Matterport scanner to a Leica scanner, and I'm kind of thinking, Jay, you'd want them to reach out to their sales rep regarding that.
Yeah, I would. We'd like to have a conversation for you. I don't want to, kind of go from a question on a webinar to tell you which scanner you should get. I'd want to know what it's being used for and dig into it a little deeper so we can give you the right information.
Okay, another question, is that alignment method the same that you would use for combining exterior scans with interior scans of one building?
Yes, absolutely. We have to make sure we get good common data between them. Otherwise, there's another way to do it, but the alignment method I showed is the better way.
All right. What software do you encourage people to use to handle .ecw files?
ECW. I'll be honest, I don't think I've ever worked with an ECW file. I don't know where that comes from.
Okay. Yeah, there's so many good questions on here, Jay. We might want to even, combine these and put it into a one-pager of some kind.
Yeah, if you want. So, I mean, I know it's
Yeah.
the top of the hour. We can. I don't know if you can copy and paste them into an email to me, and we can just
Yeah.
fill them out and answer all their questions in text format.
Yeah, we may have to do that. I'm kind of looking through the rest of the questions. I would say we have at least half dozen to 10 more questions left. And yeah, we are at 2. So I guess just to respect everybody's time, we'll kind of wrap up for today. And maybe work on, putting these into some type of one-pager or blog post. These are great questions and could make for a really great reference document.
Yeah, that's wonderful. And listen, everybody, I really appreciate the questions. These things are so much more fun for me when you actually ask questions and bring stuff to the forefront. So I love it. I really thank you for that.
Great. Thank you so much, Jay. And thank you to everybody who attended today. Just a quick reminder that you will receive an emailed copy of this presentation probably sometime next week. And thanks again for your time and have a great rest of your day.